Hello and welcome to Maths by SAS. Students, this is my first lesson of PTB class 9 science group book, and in this class we will be learning and discussing exercise 2.5, that is about the complex number and integral powers of iota. Before understanding the lesson, there are some key terms, there are some important points which are really helpful for the understanding of this exercise. The first important point is that we have to keep in our mind that what will be the answer for iota square, that will be always -1, and then what is a complex number or standard and general form of the complex number. Complex numbers are mostly represented by the letter Z, and complex number will be equal to Z equals to A plus iota B, where A and B are real numbers and iota, the value of iota is square root -1, and then we should have the good idea about what is the conjugate of a complex number. If we have a complex number Z equals to A plus iota B, then Z bar equals to A plus iota B whole bar, and see where the change and effect of this bar is coming, that this plus sign which is with iota, or the sign of the iota term is negative. So, it means that taking of conjugate of the complex number or writing of the conjugate of the complex number is not difficult at all. We have to change the sign of which term? We have to change the sign of the imaginary part. Okay, this is called the real part and this is the imaginary part, and in order to get the conjugate of any complex number, students, we have to change the sign of imaginary part. And moving to question number 1, question 1 says that we have to evaluate given parts, and in these all questions we can see that we are given the question with the different powers of iota, and we know the simple rule that in order to evaluate iota raised to power of any number, what we have to do is we have to express the given number as the powers of iota square. Like what I can do is that whatever is the number or the question given to us, I have to divide that number by 2. 2 3 times is 6 and the remainder is 1. So, it means that iota raised to power of 7 will be equal to what? Iota raised to power of 7 will be equal to, now look, this is the divisor. Okay, we have to write the divisor iota square raised to power of 3, and then we have to see that what is the remainder. Remainder is 1, so that will be written as iota. Now, we know that iota square is, what is the value of iota square? That is -1, -1 cube into iota, and cube of the negative number will be negative and minus iota. I hope really easy question. Moving to B part, iota raised to power of 50. So, I hope students you are clear that whatever power is given, what to do with that power. First divide it by what? 2. 2 2s are 4, 1 and 2 5s are 10, and the remainder is 0. So, we will be writing it iota square raised to power of 25, dot stands for multiplication, iota raised to power 0, and any number having index or power 0 is always 1. Now, we know iota square, the value of iota square is -1 raised to power of 25 dot 1, and the odd power of the negative number will be giving us what answer? That will be minus, and this will be -1. Iota raised to power 50 will be equal to -1. And moving to the third part, that is iota raised to power of 12. Iota raised to power of 12, very easy questions and important for your objective type examination. What you have to do is divide each power of iota by what? 2 to 6 times is 12, minus, and remainder is 0. Then what we have to do? We have to write iota square raised to power of 6, remainder 0, iota raised to power of 0, and any number having index 0 is 1. Now, iota raised to power of 2 gives you minus 1 raised to power of 6. Dot stands for multiplication, that is 1. Okay, now even power of minus 1 will be giving me positive answer. Even power of minus 1 will be giving me positive answer. So, this will be 1 multiplied by 1, which is equal to 1. Moving to minus iota raised to power of 8. So, very easy questions. Iota raised to power of 8. For understanding purpose, what we can do is that minus 1 raised to power of 8 and iota raised to power of 8. Iota raised to power of 8. Again, even power of minus 1 will be giving me positive, and I will left with iota raised to power of 8. Now, simple rule, divide this power by what? 2. 2 4s are 8 and the remainder again is 0. So, I can write it iota square raised to power of 4 dot iota 0. Iota square is minus 1 raised to power of 4, and then the even powers of minus 1 will be giving me positive answer. Moving to the next part, that is minus iota raised to power of 5. So, what we can do, students, here, that minus iota raised to power of 5, I can write minus 1 raised to power of 5 into iota raised to power of 5. Now, what we have to do, we have to divide the powers of iota by 2. 2 2s are 4 and remainder is 1. This time the remainder is not 0. So, minus 1 has the odd power, so it will become minus, and iota 5 can be written as iota square multiplied by iota. Now, iota square has a value minus 1. Minus 1 raised to power of 2 dot iota, and now even power of minus 1 will be giving me positive, and then we have this minus sign over here. So, iota raised to power of 5 minus iota raised to power of 5 will be giving me minus iota. These all questions are really important for your objective type paper, okay, and for your short questions as well. Moving to the next question, that is iota 27. I hope you are clear that what we have to do, we have to divide the powers of iota by what? 2 by 2. 2 13 times is closer to 27 and 1. So, iota 27 can be written as iota square raised to power of 13 into iota. Iota square has a value minus 1 raised to power of 13 multiplied by iota, and now we know that odd powers of minus 1 will be giving me answer minus 1. So, that is why iota 27 will be giving me answer minus iota. Really important questions for your board examination. And moving to the question number 2, that says write on the conjugate of the following numbers. Okay, so we know that in order to take the conjugate, we have to change the sign of the imaginary part of your given complex number. It's better to name the complex number which is given if it is not marked in the question. Let z equals to 2 plus 3 iota, and in order to take the conjugate, you must have to write your complex number in standard form. And when we talk about the standard form, that means the real part in the beginning and imaginary part later. And for the conjugate, we have to mark the bar 2 plus 3 iota and see where the change will be coming. Change will be coming on the sign of your imaginary term 2 minus 3 iota. Very easy question. Moving to the second part, that is 3 minus 5 iota. First step, we have to suppose we have to give some name to this complex number. This is 3 minus 5 iota, and now z bar 3 minus 5 iota and I have to put the bar. And now see where the change has to come. Change will be coming on the sign of the imaginary part. Okay, so the change will be coming over here. I'm putting an arrow so that my students can understand this. This is one of the most important questions of your board examination. It can come either in objective type or it can come in short questions. And the next part is minus iota. First of all, it's important to write it in standard form. And when we talk about the standard form of the complex number, we know that it must have two parts. One is the real part and one is the imaginary part. Real part is missing, so we can write it 0 minus iota. Okay, and then z bar is equal to 0 minus iota, and we have to put the bar here. Z bar, where the change will be coming on the sign of the imaginary term 0 plus iota, or z bar will be equal to only iota. Okay, moving to the next part, that is minus 3 plus 4 iota. Again, suppose that z is equal to what? Minus 3 plus 4 iota. Now students, what we have to do? Now look, what we have to do, we have to put bar, that is the sign of conjugate. And now where the change will be coming on the sign of your imaginary part. Z conjugate, z bar will be equal to minus 3 minus 4 iota. And moving to the next part, let z equals to, I hope these questions are now very easy for all of my students. Z bar equals to minus 4. I'll try to make these lessons bilingual. I will be trying to use Urdu as well, because some of the students from the other schools are also requesting. And now, in order to get the conjugate, what we have to do, we have to change the sign of this imaginary part. So minus 4 plus iota. And moving to the next part, that is z equals to iota minus 3. First, write it in standard form, that rearrange this, because the real part has to come in the beginning, and then the imaginary part, and then take the conjugate, apply conjugate, minus 3 plus iota, and this will give me, I have to put the bar here, this is minus 3 minus iota. I hope you are clear that how to take the conjugate of any given complex number. For that, we have to first write the complex number in standard form, that the real part in the beginning and then the imaginary part. Then the symbol for the conjugate is the straight line. We have to put a bar on the complex number, and the role of this bar is that it will be changing sign of what part of complex number? Sign of imaginary part of the complex number, sign of the term which is with iota. Okay, I hope you are clear about this. And moving to question number 3 and 4. Moving to question number 3, and question 3 says, write down the real and imaginary part of the following complex numbers. Really easy question. First of all, what we have to do, we have to name the complex number if it's not already given, and we have to write that complex number in standard form, that the real part in the beginning and imaginary part at the second place. And we know that general our standard form of the complex number is a plus iota b. And now we know that the real part, this is the real part, and the coefficient of iota is the imaginary part. So what we can write is that real part of z is equal to real part of z. Let me confirm the question, that real z equals to 1, and imaginary part of z equals to again 1. Okay, and then the next question is minus 1 plus 2 iota. Again we have to suppose it that this is z equals to minus 1 plus 2 iota, and compare it, we have to compare it with what? General or standard form of the complex number, which is a plus iota b. A plus iota b is the real part, so real part of z equals to minus 1, and imaginary part of z equals to 2. Very easy questions. And moving to third part, minus 3 iota plus 2. Again, let's suppose z equals to, but here the problem is, students, that the complex number which is given in the question is not in the standard form. So rearrange in this step to minus 3 iota, and now when I am comparing it with z equals to a plus iota b, a is 2 and b is minus 3. So real z is equal to 2 and imaginary z is equal to minus 3. Very easy questions. And moving to the next part, that is z equals to, let me check the question. Yes, minus 2 iota. What we are going to do, we have to compare it with standard complex number. Z is equal to a plus iota b. Okay, now real z equals to minus 2 and imaginary z equals to minus 2. Really easy questions. And now moving to the next part, that is minus 3 iota. So what we are going to do, this is not in the standard form, so we can write what part of this complex number is missing, students. The real part is missing, so we can write it 0 minus 3 iota. And again we have to compare it by what? A plus iota b, which is the standard form. So a, the real part, real z equals to 0 and imaginary part of z equals to minus 3. Very easy and interesting questions. And moving to the last part, z equals to 2 plus 0 iota, and what we have to do, we have to compare it with general or standard form of the complex number, where a is the real part and b is the imaginary part. Now real part of z will be equal to 2 and imaginary part in this part is missing. Imaginary z is equal to 0. Very easy questions and important questions for your metric and 9th class board examination. Moving to question number 4, and question 4 says, find the value of x and y if x plus iota y plus 1 equals to 4 minus 3 iota. Here, students, we can see that we have two complex numbers in the equation. They are equated, so it means that these two complex numbers are equal. Let's first try to understand the condition that when two complex numbers are equal. Condition for two complex numbers to be equal is that two complex number like a plus iota b will be equal to c plus iota d if real part of first is equal to the real part of second and imaginary part of the first equals to imaginary part of the second, like a, which is the real part of first complex number, is equal to the real part of the second complex number, and for same the imaginary part of the first complex number equals to the imaginary part of the second complex number. As in the beginning, the question says that these two complex numbers are equal because given complex numbers are equal. Therefore, what we can do is that we can apply the condition that real part of the first complex number equals to the real part of the second complex number, and imaginary part of the first complex number will be equal to the imaginary part of the second complex number. So what we can do is that the given question is x plus iota y plus 1 equals to 4 minus 3 iota. So first let me rearrange the complex number which is on the left hand side. X plus 1 plus iota y, okay, 1 I have shifted over here, equals to 4 minus 3 iota. Now students, you can see that this is the real part of the first complex number and this is the real part of the second complex number, and this is imaginary part of the first complex number, and minus 3 is the imaginary part of the second complex number. So by comparison, So by comparison, it's really important to support your working with statements so that examiner can understand your working. So the real part of this complex number will be equal to the real part on the other side, and it's your choice. Either you can write in the beginning that iota y equals to minus 3 iota. Now iota is same, so iota can go with iota, and y equals to minus 3. This is giving us that real equals to real and imaginary equals to imaginary part. And now you can see that value of y is already single, it's calculated given, but for value of x what we can do is that we can shift one to other side, and x equals to 3. So x equals to 3 and y is equal to minus 3. I hope you are really clear about that how to find the integral powers of iota, and what is the conjugate of the complex number, and what are the real and imaginary parts of the complex number, and how we can find the values of unknown when two complex numbers which are equal given to us. These are the 4 main points of this exercise, and this exercise is mostly helpful in your objective type. You just have to keep the key points in your mind, and if the key points are in your mind, then this exercise will really be easy for you. Please watch and understand this lesson before your exam. Please watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.